Today I'm going to be talking about the binomial theorem, which is a way of expanding large factors. So meaning factors that have a really high exponent. Our result will be a polynomial. The first thing we're going to focus on are coefficients. Coefficients come from something called Pascal's triangle. Pascal's triangle has a 1 in the first row. The next row, we have 2 1s. There's a pattern to this triangle. There's always 1s along the outside of the triangle. The next row has a 1, and then what we do is we add the 2 numbers from the row ahead. So 1 plus 1 is equal to 2. The outside number, again, is always a 1. We repeat this pattern, so I'm going to do another 1. Then I'm going to add 1 plus 2 is 3. 2 plus 1 is 3. And then I have a 1 on the outside. I keep going as long as I need to. I'm going to add 1 and 3 gives me 4. 3 and 3 gives me 6. 3 and 1 gives me 4. Then I have that outside number again, and I can keep going. 1 and 4 gives 5. 4 and 6 gives 10. 6 and 4 gives 10. 4 and 1 gives 5. And then we have the 1 on the outside. Now, I said at the beginning that this helps us with our coefficients. So I've listed the rules of how to expand a binomial. Step 1, we're going to use Pascal's triangle. Specifically, we're going to take the exponent. So in our case, the exponent is 3. We're going to add 1 to it. And this is the row that we're going to find the coefficients that we need. So that means that we are using the 4th row. So 3 plus 1. So 1, 2, 3, 4. So I'm going to write down these coefficients. 1, 3, 3, 1. Notice that I put big spaces in between. The next thing, it says that you're going to take the first term and then you are going to have decreasing powers. So what that means is I'm going to take the x, which is the first term of the binomial. I'm going to put it next to the coefficient, and I'm going to start the exponent with the matching exponent from the question. So that's a 3. Then it's going to decrease by 1. The next thing is I'm going to take the second term. So in this case, it's a 7. And I'm going to place that next to the first term, and I'm going to have increasing exponents beginning at 0. I'm going to put in addition signs in between. The last thing I'm going to do is I'm going to simplify. Anything raised to the power of 0 is 1. So that means when I simplify this, I get x cubed. The next term, when I simplify, I have 3 times 7. So that gives me 21x squared. The next term, when I simplify, I have 7 squared. That gives me 49. I multiply 49 times 3. I get 147. And the last term, x to the 0 is 1. 7 times 3 is 343. This last row is my final answer. It's the same thing that I would get if I expanded x plus 7 times x plus 7 times x plus 7. Which you might be wondering, well, why didn't you just expand that? FOIL the first two and then multiply it by the last parentheses. We definitely could do that if the exponent is a 3. But sometimes the exponent could be a lot higher. It could be a 5, it could be a 7, and we don't want to spend our time constantly just doing multiplications. So we use the binomial theorem, which is this method of Pascal's triangle, and then patterns, to actually come up with the expansion of the binomial.